In this video, I want to go over dimensional analysis. Now, dimensional analysis is just a specific way to convert from one unit to another using conversion factors, and it's really helpful in chemistry. Let's just go through an example. All right, if someone tells you to buy 24 donuts, how many individual donuts is that? So we know, all right, there's 12 donuts in 1 dozen. We know that conversion factor. So what you want to do when you're writing dimensional analysis is you want to take what you know, 2 dozen, and you want to convert it into the unit that you're interested in. So even if you really weren't sure what the next step is, you can always draw this multiplication symbol and then the fraction. And we know that we want to get rid of dozen. Oh, and you can think of this as 2 dozen over 1, just to make it into a fraction. We want to get rid of that dozen there, so since that unit is on the top, it must be on the bottom over here in this next fraction in order for them to cancel. Now we can think about, all right, what do we want to relate a dozen to? Well, we want to relate a dozen to individual donuts. All right. Now that we've got our units, our dozen and our donuts, now think about what numbers go where. So there's 12 donuts in 1 dozen. So we can simplify this to 2 times 12 donuts over 1. Or that's just equal to 24 donuts. So when you are setting up calculations for dimensional analysis, you want to first determine what units you want to end up with. And then you figure out how to set up the problem to get there. So you need to think about your units first, and then you can go ahead and do the problem. Let's try an example. How many centimeters is a piece of paper that is 11 inches long? And we know that there are 2.54 centimeters in an inch. So first thing, what do we want? We want centimeters. And what do we know? We know inches. And then do we know a conversion factor? Yes, 2.54 centimeters equals 1 inch. So now our next thing is, the first piece of information you want to write down is what we already know. So we know 11 inches. Then we know we want to get rid of inches, so that unit goes on the bottom. We want to get into centimeters, so that unit goes on the top. And then we fill in our numbers. There's 2.54 centimeters in 1 inch. So our answer would be 27.94 centimeters. But then don't forget about sig figs, 2 sig figs, so we're going to round that to 28 centimeters. Oftentimes, you're going to need more than one conversion factor, so we're going to do that in this example. So this example is, how many millimeters are there in 5 centimeters? Now you could go directly from millimeters to centimeters, but if you don't remember the conversion factor from millimeters into centimeters or vice versa, that's fine. What you can do is you can go from your centimeters into meters, so hopefully you know centimeters to meters, and then once you're in meters you can go into millimeters. So we're going to do a couple steps here, but the process is the same. First thing, we figure out what we know. We know centimeters. We want to get into millimeters, but it's fine that we don't do that right in this step. So we definitely want to get out of centimeters, so that goes on the bottom. And think about a conversion factor you know. So you know centimeters to meters. Now fill in the numbers. There's 100 centimeters in 1 meter. Okay, so now our centimeters are canceled out, so our number is in meters. You could solve right here if you wanted. That's fine. I just like to continue on. So now we know we want to get out of meters, and we want to get into millimeters. And there's 1,000 millimeters in 1 meter. So our answer would be 5 divided by 100 times 1,000. So we get 50 millimeters. Okay, let's try another problem that actually takes even more than 2 steps of dimensional analysis, but it's the same exact process no matter how many steps you have. All right, how many minutes are in a year? So we know we're dealing with 1 year, so we're going to write that down first. And again, we can write that as over 1. So we're going to write our fraction. We want to get rid of year. It's on the top, so we must have the unit of year on the bottom. So what conversion factor we know that deals with years? Well, I know a conversion factor between days and years. There's 365 days in 1 year. Okay, but days doesn't get us to our goal of minutes, so we need to keep going. So days is on the top. We want it to cancel, so that means days goes on the bottom. And what's a conversion factor we know dealing with days? Well, we know hours to days. There's 24 hours in 1 day. Still not to minutes, though. So we have hours on the top. We want it to cancel, so we're going to put it on the bottom. Let's do hours to minutes. So there's 60 minutes in 1 hour. All right, and then that will get us to the unit we want. So in order to calculate this out, we would take 1 year times 365 times 24 times 60. Now technically you could divide by 1 every single time, but dividing by 1 is not going to change anything. So when we do that, we end up with 525,600 minutes. Now notice that we're dealing with 1 year. We're dealing with exactly 1 year, so that's an exact number. And then this is an exact number, and this one is, and this one is. So we don't really say that this has 1 sig fig, that has 3, that has 2, and that has 2, or 1, sorry. These all have unlimited sig figs, that's why we keep this many sig figs in our answer. All right, another example that has a slight twist to it, but it's still the same process. So we know that a car travels down a highway at a speed of 92 kilometers per hour. So notice what the difference is here. We have something on the top and the bottom of our fraction. But that's fine, we just do the same exact process. So we want to convert this into meters per second. So not only do we have to convert the kilometers, we also have to convert the hours. It doesn't matter which one you pick first. So I'm just going to convert the kilometers first. So we want to get rid of that, so the kilometer unit has to go on the bottom. And we know we want to get into meters per second, so let's do a conversion between meters and kilometers. 1,000 meters in 1 kilometer. Okay, so you could solve here to get meters per hour, or you could just keep going. Either way is fine. All right, so we know we want to get rid of hours, so it's on the bottom, so we want to put hours on the top. And what's the conversion factor we know that deals with hours? So a good one is hours to minutes. 1 hour, 60 minutes. All right, so our hours cancel. So now look at what units you're left with. You're left with meters per minute. So not quite what we want. We want meters per second. So we need to do one more conversion factor. So we want to get rid of minutes. It's on the bottom, so it needs to go on the top. And we want to get into seconds. Now there's 60 seconds in 1 minute. Okay? And then that minute cancels. So the way we would calculate this is we do 92 times 1,000 divided by 60 and then divided by 60 again. And you would end up with 26 meters per second. All right, one more example before we go on to our practice problems. Now, this example is here to illustrate the fact that you don't need to know going into the problem what the conversion factors are. As long as you're given the conversion factors, you should be able to do any dimensional analysis problem. So we know that a rundlet is an ancient unit of volume, and it's equivalent to the volume of a cask of wine. At the Llano Estacado Winery produced 105 tons of wine. So let's just write that down because we know that's what we're starting with, 105 tons. During their first year, then how many rundlets of wine did they make? So that's what we want to get into. All right, so we don't see in all of these different conversion factors down here something that relates tons to rundlets. But what we do want to do is say, all right, I know I want to get out of tons, so is there a conversion factor that deals with tons? And let's see, yes, we have 1 ton equals 2,000 pounds. All right, great. So now, is there a conversion factor pounds to runlets? Well, no, we don't see it, and let's just cross that one off since we've used that. But what we do have is 1 pound equals 454 grams. So let's write that down. Okay, so now our pounds cancel. So let's just cross that one off as well. Okay, is there a conversion grams to runlets? No, unfortunately there isn't, but we do see that the density of wine is 0.98 grams per milliliter. So we can say, all right, grams on the bottom, milliliters on top, and there's 0.98 grams per 1 milliliter. So that uses up this. All right, so grams cancel. So is there a conversion factor milliliters to runlets? Well, not quite. There's a conversion factor liters to runlets. So let's convert our milliliters to liters. And this isn't in parentheses because this is one that you should just know. All right, so now we're in liters. So now we can convert into runlets. And I'm going to run out of room, so I'm just going to say 1R, 68.1 liters. Okay, so the way you would solve this is you would do 105 times 2,000 times 454 divided by 0.98 divided by 1,000 divided by 68.1. And when you do that calculation, you'd end up with about 1,400 runlets. All right, here are a few practice problems, so go ahead and try these on your own and then come back to the video and see how you did. So number 1, we have 0.00550 grams of salt. So I'm going to write that down. We want to know how many micrograms of salt do we have. So we know we want to get rid of grams, so it goes on the bottom. We want to get into micrograms, so it goes on top. Now there's a lot of micrograms in 1 gram. There's 10 to the 6th in 1 gram. Multiply those together and we get 5.50 times 10 to the 3rd micrograms. Now another way that you could have written this fraction right here is instead of saying 10 to the 6 micrograms is 1 gram, you could have written 1 microgram is 10 to the negative 6 grams. It's the same thing. I just prefer to keep my exponents positive, but it really doesn't matter either way. All right, number 2. If you go on a 1.5 mile hike, how many kilometers did you walk? So 1.5 miles is what we know, so we'll write that down. We want to get rid of miles, so it goes on the bottom. We want to get into kilometers, so it goes on the top. And we know that there's 1.61 kilometers in 1 mile. So we would get 2.4 kilometers because our miles would cancel, and we multiply 1.5 times 1.61. Okay, last one. A merry-go-round makes 15 rotations every minute. How many rotations is this per second? Okay, so we want to keep the unit of rotations, but we want to get rid of the unit of minutes. So it's on the bottom here, so it's going to go on the top here. And we do know a conversion factor directly between minutes and seconds. There's 60 seconds in 1 minute. So our minutes cancel, and we end up with 15 divided by 60, which is 0.25 rotations per second.